Okay, now that we've gotten a little more practice with our inequalities themselves, let's try and graph some systems of inequalities to see if we can determine our solutions when we have a set of two inequalities now. So getting started, I've got number 1 here, which we're just going to graph these two example inequalities the same way we had been, but now we're just comparing them both simultaneously to look for a solution. So starting off, we've got y is less than or equal to negative x minus 2. Let's plot our y-intercept of negative 2 here, and then we'll make our slope of negative 1 carry down a few points so we can graph it. We've got a less than or equal to sign, which means we want to make a solid line this time. And we can see that y is less than our line that we just drew. So let's shade in below the line. And we've got our first inequality done. Nice and easy. Now let's try out our second one. So this time around we've got a positive 2 for our intercept and a slope of negative 5. So we're counting down 5 over 1. Down 5 over 1. Again, we have a solid line here due to the or equal to portion of our inequality. So I'm going to go ahead and shade or draw a solid line. And now we're saying that y is greater than or equal to this line. So we're going to go ahead and shade everything above it. However, with our systems of inequalities, our point of interest is always going to be the area where they both end up being shaded, where they overlap. So that my orange and my blue both end up overlapping in this little triangle here, which means that any point that I pull out of this area of our graph will result in a true statement for both of my inequalities here. So anything inside of my triangle down here will be applicable to my original system of inequalities. Now let's try out a couple more examples of solving these. So number 2, we've got 2 more inequalities here where we already have them written in our intercept or our slope-intercept form, so we can go ahead and just graph them immediately. So I'm starting with my intercept of negative 2, and again my slope is negative 1 to start me off. So this is the same line as our first line in our other system, but that's okay. It's easier for us to graph. The only thing to note now is that since we don't have the or equal to component, we need to make sure that we're using dashed or dotted lines, which, to make it a little easier for you to see, I think I'm just going to make them with tick marks. So we've got a dashed line here because we have a strictly greater than sign. Then we've got a strictly less than sign with a new line here. So we're starting with a intercept of negative 3 now. And now we have a slope of negative 2. So let's go down 2 over 1, down 2 over 1. And again, we're going to get a dashed line here since we have a strictly less than sign. But I think it'll show up a little clearer if I make my tick marks again. So I'm going to do it like that. So now we have our 2 dashed lines, and we just need to figure out the shading for both of them. So start off with my first one, was my orange line. We said y is greater than my negative x minus 2. So that means we want to shade everywhere above our orange line here. Likewise, for our purple line with y is less than or negative 2x minus 3, we want to shade everywhere below our purple line. Which it looks like they overlap. Now in this upper corner is where our shaded regions are overlapped, giving us a region of solutions for our original system. Now that you've seen two examples, why don't you try out this third one on your own and see what you can come up with for our shaded region. So go ahead and pause the video for a little bit, work through that, and once you're ready you can unpause and we'll go through it together. Okay, so starting off, we can see this first inequality. We only have one variable here, which might seem a little bit intimidating at first, but it's actually easier for us to work with in this case. So this one's really easy to graph, where if we're just considering the point of negative 3 for our x, well, we can say, let's look at all of the places where x is negative 3 at, and we're going to draw that vertical line, which we know it's going to be a solid line this time since we have that less than or equal to. And we're saying x can always be less than or equal to our negative 3. So let's just make a wall at negative 3 and shade in everything for x that falls behind that negative 3. Now for our second one, we've got two variables again, so we're just going to graph our line. So we've got our positive 2 for our y-intercept. Now we're going to count up 5 over 3 to get our line here, which, since we have a less than sign, it's going to be another dashed line. So I'll make these ticks again so we know it's a dashed line. And we can see that this time we've got our y is less than our line, so we just want to shade everywhere below our line to give us our appropriate solutions, which looks like it results in just this tiny triangle down here of our double shaded region, so our overlapped region, giving us this bottom corner of solutions here for our system. Okay, we've got one more problem to go over. This time we're trying to decide what system is accurately represented by the graph of inequalities that we're given. So let's go through and look at all the characteristics of our graph and then see if we can determine which of our systems correspond to our graph here. So immediately, first thing I notice is that both of my lines are dashed, which means we should have strictly greater than or less than signs for both of our equations, which it looks like all four of our options fit that description. So let's move on and look at the directions that they're shaded. It looks like our darkest region is this top corner region. So that means that we have both of these individually are going to give us y is greater than our lines. So we're shaded above for both, giving us that region of overlap at the top. So we know we have y is greater than for both of these two inequalities here. But now let's determine if we can pick apart the actual specific lines themselves. So let's start off with this top line here. We've got an intercept of positive 2, and then from there it looks like we're going to go down 1 over 2, so a slope of negative 1/2 x. So that looks like our line, but then just like I said in the beginning, we have y is greater than that. So we have y greater than that line, gives us a shaded region above that, which doesn't look like any of the equations that were given. I can see that we have all whole numbers for each of these. So I'm just going to go ahead and get rid of my fraction part here by multiplying both sides by 2. And it's a positive number here, so the direction of our inequality sign stays the same. Still have y is greater than, but now we have 2y is greater than, I'll change the order of my x in constant term while I'm at it, is greater than negative x plus 4. So this is starting to look a little bit more like some of my options here, but I think I'm going to add an x to both sides so that I can get my x and y terms on the same side here. So now we have 2y plus x is greater than 4, which this does fall into, it looks like all of my options, or 2 of my options have a greater than, 2 of them have a less than sign. So let's get rid of A and C, which is going to leave us with B and D for our first 2 guesses. Now let's pick apart our second inequality, which this one is much trickier to tell, but that intersects at our y-axis at a positive 1/5 here. So let's make that a 1/5. And then we're saying we're going to go, looks like down 1 over 5. So we have a slope of negative 1/5 x. And like I said previously, we're using a dashed line and it's greater than. So we want to have a y is greater than, strictly greater than our 1/5 minus 1/5 x. Now let's do the same thing where we're going to get rid of our fractional terms here and just multiply both sides by 5. So now we have 5y is greater than 1 minus x. And again, I'm going to bring my x term over. So we have y and x on the same side. And we get 5y plus x is greater than 1, which it looks like this one we had a less than 1 here. So we can get rid of letter D, giving us the final correct answer of B. So we have both of our inequalities here are y is greater than, and we have a dashed line for both. So that looks good to me. Okay, that's all I wanted to cover in this lesson. Take care, everybody. I'll see you all in our next video lesson.